Now that you have had some time to look through the example, let us work through this question. We will begin by looking through the question and highlighting the points that we need to take note of. Now, we are first told to express the sum of the first n terms of the series, which is given as such, in the form summation from r equals to 1 to n of ar squared plus br. Hence or otherwise, with the values of a and b obtained, we are supposed to find the sum from r equals to 21 to r equals to 40 of ar squared plus br without using a calculator. And we are in fact told that we can make use of the following result. But first, before we can begin evaluating anything at all, we need to determine the constants a and b. Now let us move into the example proper. Our interest is first in looking for the values of a and b. So what we can do is, we know that we have exactly two unknowns, right? Now in order to solve for two unknowns, we are going to need actually two equations. Okay, we know that the first term of this sum is going to be 5. And this term 5 is at r equals to 1. So this means that when r equals to 1, a times 1 squared plus b times 1 must give me 5. And this will give me my first equation in terms of a and b. So similarly, when r equals to 2, I know that I will get the second term of my series. And when r equals to 2, my second term is in fact 14. So a times 2 squared plus b times 2 equals to 14. And this will give me my second equation. So if we were to solve these two equations using an equation solver or by GC, we will in fact obtain the answer that a is equal to 2 and b is equal to 3. Now hence or otherwise, with the values of a equals to 2 and b equals to 3, we are going to look for the sum from r equals to 21 to r equals to 40, which is exactly the sum over here. So we are interested in evaluating this sum. Recall earlier that I said that we are going to have to use the formula on r squared. So this means that I'm going to actually have to split my sum. Okay, so please make a note down as you copy that we are in fact going through the process of splitting the sum. And hence we can apply a formula. Alright. Now over here, what is happening is we are changing the lower limits. Why are we doing this? Because if you remember, in our formula given, we are starting from r equals to 1. This is a key point that I highlighted at the beginning, which means that to apply the formula, I have to ensure that my lower limit is always 1. But in fact, if you look back at the question, what we are asked to find is r equals to 21 as the lower limit. Hence, we are going to have to change the lower limits to r equals to 1 before we can apply the formula. So some of the sharper students will notice that over here, I in fact do not need to change lower limit. Why is this so? This is because over here what we are applying is sum of AP, and my first term, if I were to write out the sum, is going to be 21. Common difference is going to be 1. Okay, so over here, we have taken into consideration that my first term will be 21. We are not applying a formula, so we do not have to change the base. So applying the formula, what we are going to have is, this is going to come from the green portion highlighted above, and from the sum of AP, we will have this term. Alright, not forgetting the times 3 over here, as well as the factor of 2. So if you are very careful and you evaluate using your calculator correctly, you should get a value of 40,370. Example 12 is one of the prelim questions from Catholic Junior College. And this is indeed a very standard type of question, which involves partial fractions, finding a sum, and hence using this we will evaluate another series. This is a question which will actually stump a lot of students because they are actually unsure, especially when it comes to part 3. So please pay special attention when I'm going through this question. Now in the first part, we are asked to express 4 minus r over r times r minus 1 times r minus 2 in partial fractions. So for part 1, I expect you to go through this yourselves, and if there's any problem, we will work through it in detail in the tutorial. So for part 1, I will not be going through. You should simply get a equals to 2, b equals -3, and c equals to 1. Okay, hence we are asked to find the sum from r equals to 3 to n of 4 minus r over r times r minus 1 times r minus 2. Okay, now what is the keyword in the question? The keyword is actually hence. So this means that I have to, without fail, I have to make use of the answer that I found in the previous parts. So let's do a little comparison. What are the similarities here? Immediately I can see that, hey, isn't this term exactly the same as this term? Pardon the mess. Alright, but we see that in fact, the two terms are the same. So this means that I'm going to make use of the sum expressed in partial fractions. Okay, so immediately I can rewrite this using part 1. I rewrite it using partial fractions. And my sum is still the same. Okay, so the term is still equivalent. Now, what do I see here? I observe that I have 3 similar terms, right? I observe that I have a subtraction sign, and I observe that it is all within a sum. This should be points to note to lead you to think of using method of difference. Okay, so let us now do the evaluation of this sum using the method of difference. Now I'm going to work through this on a different note. I understand that yours will be printed for you, but I do want to walk you through the method of difference once more because this one is slightly more complex. So basically we are going to start with r equals to 3. So with some simple substitution, I'm going to have 2 over 3 minus 3 over 2 plus 1 over 1. Okay, and this is for r equals to 3. Now next, I have to plus, remember this plus, this one is important. Okay, the row for r equals to 4, which is 2 over 4 minus 3 over 3 plus 1 over 2. This is for r equals to 4. Now so far I do not see any cancellation yet. Okay, minus 3 over 2 plus 1 over 2, this is not going to cancel. So let me write down maybe one more row. I'm going to have 2 over 5 minus 3 over 4 plus 1 over 3. This is for r equals to 5. What do you notice about what I'm doing so far? Now, please take down this note at the side. This is not printed in your notes. Observe that I do not simplify my fractions. Okay, this is to ensure that I can see the cancellations more easily later on. So over here, returning to the problem, I can see that 2 over 3 minus 3 over 3 plus 1 over 3, these 3 terms, they have the same denominator. And if I were to do the calculation, 2/3 minus 3 over 3 plus 1/3, this is going to give me 0. So these 3 terms will cancel. So just to ensure that this cancellation is correct, let's do it for one more time. And indeed, we see that this pattern continues. 2 over 4 minus 3 over 4 plus 1 over 4. So this row is also going to cancel. So similarly, I can expect it to go on cancelling this way. Now, how do I work backwards? Recall that in this case, we have 3 terms, right? So let us write a few more rows before we end. Okay? So my last row will be for r equals to n. And I'm going to have 2 over n minus 3 over n minus 1 plus 1 over n minus 2. Sorry about that. And the row before that will be just one before r equals to n. It should be r equals to n minus 1. So this is going to give me 2 over n minus 1 minus 3 over n minus 2 plus 1 over n minus 3. Okay, And one more row before that, it will be for r equals to n minus 2. I will have 2 over n minus 2 minus 3 over n minus 3 plus 1 over n minus 4. Okay, so let's put a big bracket around the entire sum. Remember that this is something we cannot forget for method of difference. Okay, so a big bracket to denote that this whole chunk of terms is in fact one sum. Now how is the cancellation going to go over here? We can see that this is going to cancel, right? With the term before that. And it's going to be cancelled this way. And finally, 2 over n minus 2 minus 3 over n minus 2 plus 1 over n minus 2, this is going to cancel. So whatever is remaining are the terms which we are unable to cancel. Okay, so allow me to highlight. The terms remaining will be negative 3 over 2 plus 1 plus half plus 2 over n minus 1 plus 2 over n minus 3 over n minus 1. Okay, so now we are ready to return to the problem. This is what should have been printed in your notes. It is essentially what I just went through. So as what I've mentioned, the terms that we have remaining will be this 3 as well as this 3. So to write it down, I will have this, and simplifying, I basically get this. Okay, so this is my final answer. Okay, now we come back to the main focus of this section, which is on how I can apply what formula I've just proven to evaluate this sum. Now observe that what I've proven is on the sum from r equals to 3 to n of 4 minus r over r times r minus 1 times r minus 2. Okay, but over here what I need to prove is on this. So what's the similarity and what's the difference? Firstly, I see that one of the similarities is that there are 3 terms in the denominator for both cases. Okay, but it just seems that instead of r minus 1 and r minus 2, now it's r plus 1 and r plus 2. Okay, at first glance it seems like the r is the same, but instead I would like you to think of it this way. Isn't it true that these are 3 consecutive terms and these are also 3 consecutive terms? It's just that this one starts from r and goes backwards, so the lowest one is r minus 2, whereas this one starts from r and goes upwards, so the lowest one is r. Okay, so in fact, if I were to replace r with r minus 2 inside this, so comparing the two, what I see is, in order to get from my answer in the second part, or rather my expression in the second part, to what I need to evaluate right over here, I see that what I need to do is to replace r with r minus 2 into my sum given in part 3. So how would this work? Or perhaps I should explain in greater detail. Okay, so if I were to do the replacement as I mentioned, I would end up with this. And to give you a little bit more of an explanation, what's happening here is this r has been replaced with r minus 2. So each of my r is replaced with r minus 2. So this r is replaced with r minus 2. This r is replaced with r minus 2. And finally, this r is also replaced with r minus 2. And if I were to simplify this, I find that, hey, isn't this exactly what I want? Okay, isn't these two exactly the same expression? And for those of you who still cannot quite see it, allow me to show you that it is because if I were to rearrange the denominator, I would get this. And substituting in n plus 2, so this is using part 2 with upper limit as n plus 2. And simplifying, I will end up with this. So the key point here is in seeing the similarities between what I have and what I need to show. Okay.